Good day, everyone. I am Takis Villafranca, and today me and my group will be presenting our project for CSS142 Lab, which is entitled Optimizing Cinema Ticket Queues Through Simulation to Improve Upon Customer Experience and Efficiency. So, for our table of contents, it includes the abstract and introduction, literature review, methodology, simulation design, results and analysis, and conclusions and recommendations. So, to begin, here is the abstract and introduction. So, for our abstract, it mainly consists of the problem long queues at cinema ticket booths reduce customer satisfaction and service efficiency. And our main objective is to identify the most effective queuing strategy to minimize wait times and improve throughput. So, for our methodology, we use the Python using SymPy, and then we tested it through three queue disciplines: first come first serve, round robin, priority based, and scenarios with single versus multiple queues plus online booking channel. So for our introduction, Philippine cinemas often experience long queues during peak hours, frustrating customers and affecting revenue. While online ticketing exists, many still prefer walk-in transactions. And with that, poor queue management, especially in old theaters, worsens the problem. This study uses a discrete event simulation to test different queuing strategies, and it aims to reduce wait times, improve service efficiency, and guide cinema operators in making data driven decisions. The findings of this study are also applicable to other high volume services such as hospitals and government offices. So moving on to our research questions, we have three. One, how do queue types single, multiple, and hybrid affect service performance? Two, what is the impact of integrating online booking? And three, which discipline, first come first serve, round robin, and priority balances fairness and efficiency? So for our objectives, we will be simulating ticketing scenarios using the SymPy or Python. Number two, we will analyze the wait time, queue length, and service rate and utilization. And lastly, we'll be recommending improvements for real world implementation.
To better understand how customer waiting times can be minimized in cinema ticketing operations, it is important to first examine existing research on queuing theory, simulations in service systems, and the application of modern tools like SIMP in operations research. These areas provide the theoretical and practical foundations for analyzing service efficiency and testing improvements before real world implementation. Reviewing these works helps establish the relevance of simulation based approaches and their potential contribution to addressing ticketing challenges in Philippine cinemas. Queuing theory provides the mathematical foundation for analyzing service systems where customer demand and resource availability interact dynamically. The MM1 model, which assumes a single server with Poisson arrivals and exponential service times, establish key performance metrics such as average waiting time, queue length, and system utilization. Its multi-server extension, the MMC model, incorporates multiple service counters and uses formulas like Erlang-C to predict waiting probabilities and system efficiency. These models are especially useful in settings like cinema ticket booths, where customer arrivals peak during specific times, and provide a theoretical baseline for evaluating queue performance before implementing real world solutions. To capture the variability and complexity of actual service environments, researchers often turn to discrete event simulation, or DES. Unlike static formulas, DES models system changes as a sequence of time-based events, allowing flexible analysis of dynamic customer flows and service interactions. Studies such as those in healthcare settings have demonstrated its effectiveness in reducing wait times and optimizing resource allocation. Tools like SIMPy, an open source Python package for process-based simulation, make DES widely accessible by enabling the modeling of entities, queues, and resources while integrating with Python's statistical analysis capabilities. Recent research has highlighted SIMPy's usefulness in operations research for designing efficient service systems, making it a valuable method for studying and improving queue management in industries like cinema operations.
Let me first introduce the methodology used in the study. We implemented a discrete event simulation or DES to model the cinema ticketing process and evaluate different queuing strategies. This approach allows us to simulate the system as a sequence of events over time, such as customer arrivals, queue assignments, and ticket processing. Our simulation was developed using Python and using the SymPy library, which is specifically designed for event-driven systems. It enabled us to capture the randomness in customer arrivals and service durations, making the simulation more realistic. We tested three main queuing disciplines: first come, first serve, and round robin, and priority based servicing. Each discipline was tested under different queuing configurations, including a single queue, multiple counters, individual, and a hybrid. And to ensure statistical reliability, every scenario was simulated for an 8-hour operation window and repeated 10 times. This allowed us to track consistent metrics such as average wait time, queue length, service rate, and system utilization. Now, to better understand how this simulation works, let's take a look at the model system flowchart. So, as you can see, we begin at the start point where the simulation is initialized. Next, the customers arrive randomly either as walk-in customers or through online booking. This is represented by the customer arrives box. If needed, we can separate them based on booking method using a decision symbol. After arrival, the customers are redirected to the queuing system. This varies based on the selected configuration, either a single queue with multiple servers, individual queues per counter, or a hybrid setup for a priority. We then move on to the selecting queuing disciplines such as first come first serve, round robin, priority based servicing. This step determines how customers are served at counter. Once queued, the next process is the ticket service, where a ticket counter serves the customer. Finally, we log key performance metrics such as average wait time, queue length, service rate, and system utilization. The simulate concludes at the endpoint after running for a set operation period, usually at 8 hours. So technically, this flow would help you and us, the group, visualize the entire simulation system cycle and analyze which queuing strategy works best to improve customer experience and operational efficiency in cinema ticketing.
So I'll be presenting about the simulation design of our cinema ticketing system. It explores how different queue management strategies affect customer experience and overall system performance. We implemented three scenarios for our model. The first is first come first serve, or FCFS, where customers are served in strictly in the order they arrive. The second is round robin, which distributes service evenly across all counters, rotating through them to balance the load. Lastly, we implemented a priority based system where certain customer types, such as senior citizens, VIPs, or anyone that has priority, are given precedence over regular walk in customers. Each simulation scenario runs for an 8-hour operational period. During this time, we monitor and collect data on key performance indicators, such as the average wait time, queue length, service rate, and overall system utilization. The simulation assumes that all counters operate at the same efficiency, that customers do not abandon the queue, and that online bookings are processed independently from physical walk-in lines. The results showed interesting insights. In general, first come first serve provided a fair and balanced experience, particularly when customer flowed. flow remained steady. Round robin helped distribute the load across counters, but occasionally led to higher wait times when customer traffic spiked. The priority-based setup significantly improved wait times for prioritized customers such as the senior citizen, but sometimes caused delays for walk-in regulars. These trade-offs are important when designing real-world system where both fairness and efficiency must be considered. So, in conclusion, our simulation demonstrates how different queuing strategies directly impact service performance in a cinema ticket environment. So, for our results and analysis, the simulation compared three ticket booth queuing strategies: single queue, multiple queue, and a priority based system with dedicated counters for priority and online customers. Results showed that the single queue, or first come first served strategy, generally yielded the lowest average wait times for walk in customers, especially when the number of counters was sufficient to handle demand. The priority based system effectively reduced wait times for priority customers such as seniors, VIPs, or pre booked guests by assigning them to dedicated counters, though this sometimes led to longer waits for regular walk ins. Online customers consistently experience shorter wait times when served by their own counters, highlighting the operational benefit of encouraging online bookings. Trade offs were observed between fairness and speed. While the priority based approach improved service for select groups, it could increase wait times for others, whereas the single queue system provided more equitable service but did not optimize for special needs. Multiple queue with individual counters or round robin sometimes resulted in uneven counter utilization and longer waits if customers did not self-balance effectively. For cinema operations, it is recommended to use a single queue with a priority counter during peak hours to ensure fast service for priority groups while maintaining fairness for walk-ins. Encouraging online bookings and providing dedicated counters for online customers can further reduce lobby congestion and improve overall efficiency.
So what does all this data tell us? In conclusion, our simulation study shows that the best this leads us to our final recommendations on how to put these findings into action. Our overarching goal is to use these findings to improve the customer experience and boost efficiency. We can achieve this through two main channels: marketing and partnerships. Encourage online booking and reduce physical lines. For offline, we'll use clear in-cinema signage to guide customers to the correct queue, either general or priority, making the system easy to navigate. Second, under partnerships, we need to form strategic alliances. We'll partner with leading digital payment brands and channels. By integrating these strategies, we create a resilient and customer-centric solution that addresses the needs of all moviegoers and turns our research into real-world results.